resonance?
Yeah.
Where? How?
From the leftmost to the rightmost.
That's it? What about the nitrogen?
Nitrogen.
I'll ask you two questions. This is how my brain is processing. By the way, what I'm doing right here is thinking aloud, just to show you how my brain is processing it, okay? So two things. First, does nitrogen have electrons that are not shown?
Yeah.
Yep.
What? How many?
2.
So remember, we are very lazy about lone pairs, but they exist. Second question. For the moment, if you put Vesper aside, do you have allylic lone pairs?
A
Do
lone
you
pair.
have lone pair, one atom away from a double bond?
Yes.
And the lone pairs are on the nitrogen are an
So
atom away from
therefore-
each carbon.
Therefore, what if it were sp2 instead? If it were sp2, what will it have? Won't they exist in the sp2? Does this have sp2? sp2, sp2, sp2 is their resonance.
Yep.
And which atoms are involved in that resonance?
Yeah. All the carbons and the nitrogen.
All of them. So whenever you have allylic lone pairs, that atom with the lone pairs has to be sp2 period. Make a note. If you have allylic lone pair, meaning electrons, 2 electrons in the allylic position, yes, that carbon will be, that atom will be sp2, because then we can have resonance, which leads to stability. And that's where you put Vesper aside. So can this part have resonance?
An atom away from the double bonded carbon.
So can it do resonance?
Yeah.
Can it have resonance? You got lone pairs, one atom away from double bond, that's an allylic lone pair.
Mm-hmm.
Yes, there will be resonance. Are you guys seeing that? Everybody okay? Now it doesn't have to be negatively charged as long as there are lone pairs next one atom away is what really matters. Can this do resonance?
Yeah.
How, where, what?
The oxygen has 2 lone pairs and then
Exactly.
the other carbon.
Exactly. That are allylic, in the allylic position. These lone pairs are in the allylic position. So yes, it can do resonance. Yes.
A question about
Yes.
this. So, you said allylic lone pairs are always sp2s?
Yes, because then you can have resonance, which is stabilizing effect, and nature goes towards stability.
Mm-hmm.
So yes, that's when Vesper doesn't help us. Remember, these Vespers and MOs and AOs and hybrid, those are models we've created so we can understand what we do see. So Vesper doesn't match with what we do know, evidence we have. Therefore, you got to shift a little bit. If you have electrons in the allylic position, it is very safe to assume that that atom is sp2 hybridized, not sp3, because sp3 doesn't help us. Does that make sense, everyone? Everybody okay? Third structural characteristic, which will also help us identify existence of resonance, and that is allylic, but this time cation, a positive charge. But also in the allylic position. Allylic is one atom away from the double bond. So that's the third structural feature. So if you have, for example, a carbocation, by the way, cation on a carbon is a carbocation. So can it do resonance? Can
Yep.
it exhibit resonance? Yes.
Yep.
What's the hybridization states of these atoms?
sp2.
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 Mm-hmm.
Absolutely. If they're all sp2s, what is it that they have? Exactly. Resonance. You guys with me?
Yep.
Everybody okay? So let me ask you a question. Can you tell me what is the total number of electrons, now electrons, that are being delocalized in this system right here? Perfect. Do you guys agree?
Yeah.
There's one electron because of the pattern, right? And two there. Total of 4 electrons are being delocalized. You guys see that?
Mm-hmm.
What's the total number of electrons being delocalized in this system?
3.
Careful.
Oh.
How
2.
many? Just 2. Just 2.
The third part.
Why? Because there is 1 electron here, there's 1 electron there. What about that carbon atom? Does it have electrons in this p orbital? If it
It's a
has
positive charge.
So they are delocalized. The orbitals are all merged, all 3 of them. But how many electrons are being moved in that space?
2.
Only 2. Do you all see that?
Mm-hmm.
Everybody okay? How many electrons are being delocalized in this structure? I know I've made a mess of it, so maybe I'll just draw it again. This structure.
6. 1, 2, 3, 4.
I heard 6.
Yeah.
Is everybody okay with this? So resonance is not a process. Resonance is not one structure becomes another, then it becomes the first structure again. No, that's the wrong way of looking at resonance. Resonance, on the other hand, is a phenomenon. And resonance structures are just drawn for our convenience. They don't actually exist. What exists are the hybrid of all resonance structures that we can draw. Are we all okay?
Mm-hmm.
Cool. So let's now practice resonance structure drawing and then hybrid drawing and so on.